Hello and welcome to the NavAbility tutorials. This is tutorial 4 on leveraging prior, possibly contradictory data. How do you bring knowledge that you have or judgment or experience into an automation system that's based on measurements and sensor data? How do you bring those two together? And we're going to base it on a specific example. If you haven't seen before, we have a separate getting started videos on how to set up your environment. Go check that out if you haven't already. We also have 0 install options I'll show in a moment. We're always curious at NavAbility to hear how we can help. If there are any questions or any ways you think we might be able to engage and help, please do reach out, either through our website, www.navability.io, or an email info@, and then our Slack channel, which is linked in the description below, or you can find it on our repositories and on our website. We're happy to discuss more. This tutorial is very applicable to a number of problems faced out in the wild where you have prior information and you've got new measurement information. You're trying to bring those two things together somehow. And then the issue of discrepancy when these things don't necessarily fit, when the measurements don't fit what you're expecting. So to highlight very specific examples, think about manufacturing and picking and placement or packing of objects where you know how you want the robots to work and what you're expecting to see, but now you want those robots to be a bit more flexible and engage with asynchronous measurement data to slightly sort of adapt their behavior on the fly, but not veer too far from your prior programming. That's a clear example. Another is in construction, total stations that surveyors use to measure out the world or the site. They may have a design plan that they're expecting to see and measure. What happens when the measurements don't match what you're expecting to find? And especially if you want to automate and reduce cost on these total stations, dealing with that discrepancy can be very challenging, and this technique we're suggesting will really help. So any kind of situation where you have an as designed versus as built in construction, even if it's cell phone data or if it's LiDAR data, any kind of information that's collected from a construction site that is being compared to the digital model, how do you detect discrepancies? How do you deal with that? How does the AI process that information together? Not just for buildings that are big. Another example is in manufacturing. Think about a part. You're manufacturing a specific part, use metrology to measure it out, and how do you compare and detect discrepancies between what you're expecting to find from the modeling and what you're actually measuring with a real system. And there are cost implications of absolute versus relative measurements. We'll go into that a bit. The same idea also happens to apply to if you have prior knowledge of an area you're trying to localize in. Think about underwater. If a diver swims next to a ship and they see the propeller or the rudder, they kind of have an idea of where the rest of the ship is. Where's the bow and where's the stern? That prior information of how a ship looks is very applicable here too, and we can help program robots to do the same thing. This extends to subsea infrastructure, offshore energy, wind or oil and gas, aquaculture, etc. I'm sticking with discrepancy detection. Any situations where you're inspecting, you collecting data from human-operated, teleoperated, or autonomous vehicles. You're collecting data for inspection, and you want to compare the collected data versus what you're expecting to find and detect autonomously any discrepancies between it. This technique is very applicable. A good example there is kelp farming. You've got lines strung underwater, and you're expecting them to be held firm. And the robot might go out and with a low-resolution sonar measure it up, and you want to discover whether any of those lines have broken down. That's very applicable. And there are many more. We wanted to just highlight these few. This tutorial is going to follow a simple two-dimensional example where we're mapping a rectangular shape where we have some prior knowledge about it, as shown here, where we take the 4 corners as primary pieces of information. We call those navigation-affordances. And then there's also a door, and we're not sure about where the hinge is. We want to confirm that in measurement. And we think we know which side it's hinged. And this tutorial will show that there's actually a contradiction in there and how the solver deals with that contradiction, which is unique. So it's all about how do you bring prior information together with new measurement information and that duality of when these two things don't match. The way the results are going to look, something like this. On the right hand side, let's start here. We're going to build factor graphs, in this case multi-hypothesis factor graphs. This is which variables and measurements are associated with each other. On the left are actually the numerical values that are solved and contained inside the factor graph. So at this point, the robot probe has moved through 3 positions, x0, x1, x2, and there are 2 hypotheses currently being tracked. So there's the rectangular shape, and then we follow purple, red, green. So purple down here, red, green, that's one hypothesis, or from the top left, purple, red, green, that's a second hypothesis. And the example goes well beyond this and shows more and resolves contradictions, etc. At the end of the example, we link out to a construction application example where navigation affordances are used. Here we're showing floor plans where the as designed in blue and the as built measured in red is ultimately detected as a contradiction. So we invite you to see that. There are 2 ways in which you can run this tutorial, either through our cloud solution Zero Install or getting it locally. I'll click through each of those to quickly show. So let's go to app.navability.io. You can also just type that in. This is our app. On the burger menu, there's a tutorials. This is tutorial 4 on the right, leveraging contradictory data. And you can choose your own adventure. So let's say Python, NavAbility SDK. And if you click that, it'll spin up a separate instance that you can try and run. It'll take a bit of time to boot. The other option is to install and run locally on GitHub NavAbility. So I'm going to click there. So NavAbility binder notebooks. There are multiple languages. Let's say Julia, the Caesar API, tutorial 4, Wicra number 4. This is the same content, and you can run through it locally as you wish as well. Link below is a separate video that actually walks through this tutorial 4 and will show you how all the parts work. Look out for that and the other tutorials. Thanks.